Most of the printout looks ordinary. Then one section suddenly rises above everything around it. A single signal appears where nothing that strong is expected to be. In 1977, the Big Ear radio telescope records a powerful narrowband radio signal lasting about 72 seconds. On the printout, astronomer Jerry Eman circles the data and writes a single word beside it. Wow. The reaction is not caused by a vague anomaly or a questionable reading. The signal stands out clearly enough to stop someone in the middle of reviewing routine observations. It leaves a mark on the page and immediately creates a new priority. The obvious next step should be simple. Check it again. Track it. Confirm where it came from. But that opportunity never arrives. Before anyone can follow the source, before a second observation can be organized, the signal is gone. The event is recorded. The evidence remains on the paper. The transmission does not. And one problem appears immediately. If the signal was real, why did it happen only once? The easiest explanation is still sitting on the table. Maybe the signal was never real. Maybe a piece of equipment malfunctioned. Maybe some brief interference slipped into the data and vanished before anyone noticed. That possibility survives only until people look more closely at what was actually recorded. The signal does not behave like random noise scattered across a system. It arrives in exactly the kind of form the Big Ear telescope was built to detect. It is unusually strong. It stays confined to a very specific range of frequencies. Most importantly, it appears and fades in a way that matches the telescope's normal sweep across the sky. The pattern creates a problem. A technical glitch can produce a strange reading. But a strange reading that also behaves the way a real target should behave is much harder to dismiss. The printout no longer looks like a machine briefly misbehaving. It looks like the telescope encountered something and recorded it as designed. One safe explanation after another begins losing ground. The signal is gone, but the data refuses to cooperate with the idea of an ordinary error. The event becomes harder to file away, harder to ignore, and harder to reduce to a simple malfunction inside the system, which leaves a more uncomfortable failure. If the observation was significant enough to survive those doubts, why did every later attempt to find it again come back empty? The search does not stop after the first disappointment. Researchers return to the same region of sky again and again. Different instruments listen. New observations are scheduled. More time passes with antennas pointed toward the area connected to the original event. The logic feels reassuring. If the signal came from something natural or from some ordinary source that still exists, then eventually it should appear again. Maybe not tomorrow, maybe not next month, but given enough observations, another detection seems likely. That expectation slowly becomes the working assumption. The original signal still exists in the data. The doubts about a simple equipment failure have weakened. The signal no longer seems mysterious. It seems overdue. Every year without an answer starts to feel less like a setback and more like a delay. Observations continue. Equipment changes. Searches return to the same patch of sky. Each new attempt carries the possibility that the missing signal will finally reappear and turn a strange moment into a solvable problem. The situation starts to feel predictable. The source may be unknown, but the path forward appears clear. Keep watching. Keep listening. Let time do the work. After all, if something produced the signal once and still exists, finding it again should eventually become a matter of patience. At least, that is what the search still seems to promise. The next detection never arrives. Then another year passes. Then another. Researchers keep returning to the same region of sky, expecting the missing signal to eventually reveal itself. Instruments listen. Observations accumulate. New searches begin where older ones left off. Nothing returns. The absence does not arrive all at once. It grows slowly. Each new observation creates another opportunity for the signal to appear. Each observation ends without the confirmation everyone is waiting for. The expected second detection remains just beyond the next search, then beyond the one after that. Eventually, decades stand between the original event and the present. The prediction that once felt safest begins to fail. If the source still exists and behaves in an ordinary way, repeated observation should gradually increase confidence. Instead, the record remains frozen around a single moment. The original detection survives every review. The second detection never appears. That changes the nature of the problem. The obstacle is no longer finding the source. The obstacle is that the only piece of evidence cannot be tested a second time. The event happened once, left the record, and then stopped participating in the process that normally turns observations into certainty. A single observation can start an investigation. A second observation is what usually keeps it alive. Here, the procedure keeps reaching for a second observation and finding empty space. The signal refuses to disappear from the record. The confirmation never arrives to close the case. And an uncomfortable question begins to replace all the earlier ones. What happens when an observation may matter enormously, yet never gives anyone a second chance to test it? The wow signal does not disappear from astronomy. The printout still exists. The observation remains in the record. The 72-second event is still treated as something that was genuinely detected. What changes is everything that failed to happen afterward. Researchers cannot reproduce it. They cannot confirm it through a second observation. They cannot completely remove it from consideration either. The signal remains fixed in place, suspended between competing outcomes that never receive a final test. That exposes a limit that has very little to do with telescopes. The instruments worked well enough to record the event. The problem arrives after the detection. Verification requires another opportunity, another observation, another chance to compare what happened before with what happens next. That chance never comes. So the wow signal occupies a rare position. It is not remembered because a solution was found. It is remembered because the normal path toward a solution never became available. The most remarkable part of the event may not be whatever produced the signal. It may be the fact that the opportunity to investigate it lasted only 72 seconds. Everything that came afterward depended on seeing it again. That second chance never arrived. The observation survived. The verification did not.